Okay, hi Benny boy. Okay. 2.4, you need to be able to find the area under a curve given in parametric equations. Yes, by all means, you could change it to Cartesian and then integrate with respect to x. But that is tedious unless you're told to do it as part A to a question. If it's given as a question straight off, then there is another technique. Okay? And you can see the technique quite clearly here. You know that the area under a curve is the integral of y dx, okay, the summation of all those rectangles, y dx. But we're going to, these are in terms of t, so we know that if we replace this using the chain rule, dx by dt times by t actually, times by dt actually is the same as y dx. So what it's saying is to integrate parametrically, you do y, that's in terms of t, times by the differential of x with respect to t, and then integrate it with respect to t. So that's all it's saying. So that is what we use, right? So looking at this, we need to find the derivative of that with respect to t. So dx by dt is going to give you 10t. And as you can see, the area is equal to the integral of y dx by dt with respect to dt. That is now going to give you, well, you can see they've given you in this format already. So they've given you the limits. These limits are in terms of t already. So it is this times this. So I've got basically t cubed multiplied by 10t with respect to t, with the limits 1 to 2. So that now gives you the integral, obviously, of, I'll do it over here, is equal to the integral 1 to 2 of 10 even, t to the power of 4 dt. Now, not that you need to do it here, but you can pull constants out of the integral sign. So I'm pulling a 10 out. It does help things usually. No big issue here though. So integrate that, and it gives you 10 big square brackets, and you've got t to the power of 5 over 5, and I've got 2 and 1. And you can see on this occasion it doesn't really help because you're going to cancel that out, so it would really give you 2t to the power of 5 there. 2t to the power of 5, and you've got 2, or 1 to 2. Right, upper limit take lower limit. So 2 to the power of 5 is 32, times by 2 again is 64, minus the lower limit shoved in, which is 1, and that's going to give you 2. So the overall answer to that question is 62, well, I wouldn't say units squared because we don't have an area under a curve, but that's the answer. Okay, don't know what the parameter is to do with, so that's the answer. 62. Okay, over the page. Right, the diagram shows a sketch of the curve with parametric equations x equals blah blah, y equals blah blah. The t is greater than or equal to 0. The curve meets the x-axis at x equals 0 and x equals 9. The shaded region R is bounded by the curve and the x-axis. So again, find the value. This is the technique. You have to change the limits because our limits now need to. If we're going to integrate with respect to t or parametrically, then the limits need to be in terms of t. So we're going to put x is 0 into there. So we've got our x value and our t value. That's the way we usually do it. Okay, little table. And the x value is 0. And that means that you've got square root of 0 is 0. And if you put x is 9, and the square root of it is plus or minus 3, but you want x is greater than 0 or equal to 0, so it's positive 3. Okay? So, you're now going to go to parts, that's part 1, that's part 2, and we're now going to go to part B. Right, find the area R. So, we know that it is the integral of y dx by dt dt, and the t limits are, as you can see, from 0 to 3. So 0 the lower limit and 3 the upper limit. Okay. and that gives us, well, I'll do it over here, y is equal to 0 to 3, y has the value 2t, brackets 3 minus t, and it's all times by dx by dt. Well, I need to differentiate that, so I'm going to need that. I'll slot that in just here. Dx by dt is equal to 2t. So all of that's got to be times by 2t and integrated with respect to t. Okay, I would expand this out, so that's 4t squared gives you 12t squared. 4t squared times for that is minus 4t cubed, and I'm integrating all of that with respect to t from the limits 0 to 3, and that will work out the area. So big square brackets, I've got, now I could pull a 4 out as I've just shown, you can pull constants out, but it's not going to help here. Right, so add a power and divide by the new power, so it gives you 4t cubed minus, add a power is 4, divided by the new power is t to the power of 4. The limit's 0 to 3, you shove the upper limit in, 3 cubed is 27, 4 times 27 is 108, minus 3 to the power of 4 is 80, 3 to the power of 4 is 81 miles away. Okay, take away the lower limit, well that's just going to be 0, and therefore it is equal to 19 plus 8 is 27 units squared, as you see it is an area now. Okay, so that's that one done, that's the region, parametrically. Okay, right over the page. And that's wonderful, Benny boy, because there's another exercise for you to miss and think you can't do, but now we've videoed it, so you are due for the deadline just like anyone else is. And how many questions are there? 8, 9, 10 simple questions. Give it a shot. End of recording. Good night.